The first concept that I want to introduce you to is the concept of purity. This is something in every functional programmer's tool belt, and it's one of these ideas, or rather, its opposite, impurity, is very common in traditional programming, and it's so common that it's not even really recognized as an idea. But there are problems with it, and it's better to write programs without it. So I want to introduce you to the concept of purity. So purity is an attribute of functions. A function is either pure or it is impure. And in order to be pure, it has to meet two criteria. The first is it doesn't cause any side effects, and it doesn't have any side causes. I'm going to go into what that means. And the second is it doesn't, for the same input parameters, it always returns the same output. It always returns the same value. So its behavior won't change for the same inputs. Now, here are some examples of impure functions. This first example takes an input A, that's a number, and then all it does is it takes the value of the counter, which was declared up here, and adds A to it. Now, this function is impure, and that's because it has a side cause. And counter is a side cause in this instance, because counter is not familiar to us within the context of this function. Counter was sort of incorporated from the outside, and the value of counter may change. So as a result, if the value of counter is currently 0, well, then we're going to return 0 plus A. But if the value of counter might be anything, because who knows if maybe somewhere else in our code we are changing the counter, and then that is going to affect the behavior of this function. It's going to affect its return value. So this is an example of something where it's harder to reason about an impure function because it has dependencies in the outside world, so to speak, in lines that do not belong to it. Now let's look at a different example of an impure function. This function is even simpler. All it does is it increases the counter by 1. This function has both a side cause and a side effect, because what it does is it takes the counter as a side cause. It's not explicitly given the counter. It takes it as a side cause, and then it changes the counter. If the counter is currently 0, this will change it to 1. If the counter is currently 10, this will change it to 11. So that's a side effect. So the behavior of this function, both the data it operates on and the effects it has are going to change, or may change at least, every time you run it. So it's very hard to know what this function actually does. All you know is it increases some counter, but you won't know what the values of counter what the value of the counter was and what it's going to be after you run this function. Here's an example of another impure function. And this function is impure because it logs something to the screen, which is also a side effect. Now, a pure function is something like this. This function is pure because A, it doesn't have any side causes. It only operates on the inputs that it is given, A and B. It doesn't have any side effects. It doesn't print anything. It doesn't change anything. All its effects are constrained to the realm within itself. And lastly, it does the same thing every time. So every time we invoke it, if you invoke it with, if A is 2 and B is 3, it's always going to return 5. That's never going to change. So it's much easier to reason about this function, and therefore also to maintain it if you want to change it. If it had an effect on its outside world, it'd be harder to reason about. But this function is the same thing every time, and is therefore very easy to reason about. Now, in the example up here, it may not seem like such a big deal, that counter comes from outside the function. Of course, this is an artificially simplified example. In a real-world application, what you may find is that you have a much larger function and it has a lot more side causes, a lot more dependencies from the outside world. And who knows when and how those change. And they may all be related in intricate ways. And so this quickly explodes into, much more complexity. That's why it's a good idea to avoid that. Now, it might not be possible always and every time to avoid impure functions. Sometimes you want to log something to a screen. Sometimes you want to change some state somewhere, and that's fine. But as a general rule, it will make your programs clearer and simpler if you write pure functions rather than impure ones.